we're going to continue ways to find limits without calculators. If you want to use your calculator to check your work, you're always welcome to do that, but the best way is to be able to do this no calculator. So, same idea as before. I'm going to take the limit as x approaches 1. If you plug in a 1, 1 minus 1 is 0, and you can't divide by 0, obviously. So I want to know, is this one of these equations that has an asymptote, which means nothing cancels, or is this an equation that something does cancel, and it's just going to have a hole? So is there a way to simplify this? Well, we have to take a power 3 and divide it by a power 1, and we have to reintroduce ourselves to some long-lost friends. If you remember, the way that we divided power 3 and higher polynomials was synthetic division. I know I can hear the collective groan coming over the internet. But yeah, synthetic division. Remember what like this. We take our coefficients and write them down. So we're going to have 1, -1, 1, and -1. And then we drew a little thing like this. We took the number that we're dividing out. And if you remember, we took the 0, which is also going to be the number that's on the limit, and put a 1 there. So if I do this division, synthetic division, quick refresher, the first number you just bring it down. So we're going to write a 1. You take this 1 and I like to put my finger right here. You multiply back. 1 times 1 is 1. Add the next and you get 0. And now we just keep multiplying back to this number. 0 times 1 is 0. Add the next for 1. 1 times 1 is 1. Add the next for 0. And we box it up because that number is the remainder. That means that it divides in evenly because it has a remainder 0. The last thing you have to do is interpret this. This, if we remember, goes power 0, power 1, power 2. So this is 1x squared plus 0x plus 1. So x squared plus 1 is what we get when we simplify. That equation becomes pluggable, meaning there's no discontinuities in it. So if I go now to my original equation, take the 1, plug it in. 1 squared is 1 plus 1 is 2. So the limit is going to be 2. If you want to graph this and see where it crosses the, or see if there's a hole in it or if there's an asymptote, you can, but you can just take my word for it that there was a hole in that one, and we just made it pluggable. All right, we're going to use a logic method on this one that you use it all the time. You just maybe don't realize you use it, because how could you take a power 1 and divide it by a power 3? Well, a similar question would be, how do you do 2 divided by 4? Well, one way that you could do this problem, I mean, you guys all would just call that 1/2. Here's how you could do it, is you could flip it and do 4 divided by 2 is 2, and then just flip it back to get 1/2. That's one method of doing it. So flip the fraction, do the division, get an answer, flip it back. And that's actually what we're going to do. So we're going to flip it. And when we flip it, I'm just going to do this bottom polynomial divided by the top one. So I'm going to go 1, -7, +7, and -49. Box it up. Take the 0, which is 7. And now let's just do our division. Drop down the 1. 7 times 1 is 7. Add this for 0. 0 and 7 make 0. Add 7 for 7. 7 and 7 is 49. Add the next, and you get 0. So my answer here is x squared plus 7. Now remember, now we just have to flip it back. So it's actually going to be 1 over x squared plus 7. So we flipped it, did the division, flipped it back. Now we have something that we can plug 7 into. And what we get is 7 squared is 49 plus 7 is 56. So it's 1/56 is going to be the limit. And I like a problem like this because if you looked at your calculator or if you looked at a table, you would assume that the limit is 0 because this is such a small number. You would say, oh, it's getting very, very small. It must be getting close to 0, but it's actually not. It's actually getting close to something really small, which is the fraction 1/56. All right, the last 2 examples. You're going to love this. Back to our good friends, the trig identities. So it's going to be helpful to quick sketch a unit circle. Can you plug pi over 2 into this? Well, if you remember what the secant is 1 over cosine. That's what it is. And a quick sketch of the unit circle, if you want to get out a unit circle, you can. But the cosine, and we're approaching pi over 2 up here, This is the point 0, comma 1. So the cosine is this value right here. So the cosine is going to be 0. So if we're putting all this together, the cosine of pi over 2 is 0. The secant is 1 over cosine, which would contain a 1 over 0, which is why it doesn't work. Well, let's see if we can straighten this mess out and make it pluggable. I picked some easy ones for you guys. So right here, the cotangent, if you remember, is cosine over sine divided by 1 over cosine. And when you do a fraction divided by a fraction, you're going to multiply by the reciprocal. When we do that, we're going to have cosine x over sine, and then multiplied by cosine over 1. Multiply that and you get cosine squared x over sine x. Now, does it simplify to something else? Maybe. But really what I'm after, if you remember, before we were trying to get it as simple as possible. Right now I'm trying to make it pluggable. Is it something that you can plug pi over 2 into? Let's go check it out. If I go to my unit circle and we go to pi over 2, the cosine of pi over 2 is 0. So this one says 0 squared. The sine of pi over 2 is 1. So 0 squared over 1 is just going to be 0. And so when we just quick did the division, when you multiplied by the reciprocal, it got this cosine out of the denominator, and now it becomes pluggable. So it's a different goal from before. You just want to find something so that when you plug pi over 2 into it, then you're able to plug the number in. All right, try the last one on your own. We've got 1 minus cosine squared. If you remember, that's a sine squared. So we get sine squared over sine x. One of these signs cancels, so you're going to get cancel and cancel. So this one really says sine x. So I want to take the limit as x approaches pi. If I go on my unit circle, this is negative 1 comma 0 is this coordinate over here. The sine value is the y, so you get 0 once again. It's not always going to be 0, but in this case, it is.